site. But we're a
try to run these other kind of boot camp SQL and advanced Spark setup. So there's two options here. You can either
Looking for great hotel prices?
want to make up or Docker compose up. So in here, I'm just going to show with Docker compose up. Now this is setting up and running all of the Docker stuff that it needs to download and install and do all of the stuff to like set up Docker. You'll see this needs to set up 4 containers. We need one for Iceberg, we need one for MinIO, we need one for MC, and we need one for Spark Iceberg. Those are going to be the 3 big things that are going to be part of this, right? And then ultimately we are going to be accessing this from localhost 8888. That will be where this is going. Make sure you have Docker set up, otherwise this is not going to work, right? And this is going to take a little bit of time because these images are really big, right? So we're just going to have to vibe here for just a little bit while this is installing, and then we will we'll go from there. Should be a pretty exciting time here as we get started, set up. And then we go here. Is it set Spark stuff? Should be pretty great. So I think if we go here, is it set up? Okay, there we go. So that. Actually set up. Then we can go into notebooks and we can go here, right? And then this should run. So you'll see we have our data pulled in here. This is all of the data that we have. And so if you can get this up and running, you're good to go for the lab. One of the things I want y'all to try is just like running this first cell, and you should get, this should actually show you some data here. It should give you back a good data set that will show you pretty much what you would want to see here around like URL, your browser family, device family, host, all that kind of stuff. So one of the things that this is probably pretty straightforward so far. We're just reading in a table. It's reading in a CSV file. That is the one CSV file that's in the repo. So, and then we're adding one column here, which is the event date. And the reason why we're adding the event date column is because we want to use that later on in Iceberg. But I actually learned that like you don't even need this column for Iceberg. Like Iceberg is actually really smart. But so I just want to kind of go over each one of these lines real quick because some of y'all might not have a ton of experience. This line actually we don't need it. So Spark is managed by this thing called the Spark session. So you want to build a Spark session. So that's what Spark session.builder does. And then usually you create some sort of app name. We call it Jupyter here, which is your Jupyter notebook. And then you do .get or create. One of the things that you might notice here about this syntax is that it's actually not Pythonic. Because if this was like a Pythonic way, right? right? This would be get or create. Right? It'd be like that. And way or create. One of the things that you might notice here about this syntax is that it's actually not Pythonic. Because if this was like a Pythonic way, right, this would be get or create. It would be like that. And one of the reasons why it's not that, and it's actually this, it's camel case and not snake case, is because Spark is a JVM library. And so even when you're using Python, PySpark, you're going to still, a lot of the libraries and functions and stuff that you're going to call are going to be JVM. Same like with this with column. It's with column, not with column like that, right? So most of the style, like this is where like PySpark can be a little bit funky because like you actually do use Java styling, but you have Python code. And the main reason for that is that PySpark, all it does is it wraps the Python, the Spark libraries in Python, so that then you can just use Python to do stuff, right? So one of the things I wanted to show real quick here, though, is you see there's .show. I wanted to show .collect. This line, this might actually out of memory. Let's try it. Oh yeah, I forget. Oh yeah, Python is so annoying. You have to put the backslashes. Okay, so you see how now we're getting a stage. It actually gave us a stage, and that actually gave us, we're actually like running Spark there. Okay, so there we go. Wow. It's because there's not tons and tons of data. So generally speaking, if this was a very big data set, like if it was actual big data, I think there's like 500,000 rows here, but like that is going to be the idea, right? Is that you can also kind of out of memory and crash Spark by calling this df.collect, right? So I kind of want to show that just because I think it's important to illustrate, right? Because you can do like a join here, or like here, let's do it this way. We're going to say dot join df, and then in this case, what we're going to say is df, or we're going to say, can we just say lit? I think we say lit1 equals lit1. So like we're essentially going to just like blow up the data set here by like doing essentially like every row matching with every other row. So this is going to make it like a lot more data. Like, and so I wanted to show you how this is going to probably crash the data set, right? Okay, there we go. So now we're saying, okay, perfect. So you see here, how what we're doing here is we have this Java heap space problem where it's like out of memory because we tried to bring too much data back, right? So what we could do, right, is if we say instead of collect, say we do like .take5. Now this should actually run. Like I'm pretty sure this will run. Okay, hold up. 1 second. Let me see, because if I try to run collect here again, it might have just died. Okay, so I straight up killed the kernel here, so we gotta like stop him in the kernel. We gotta restart the kernel here because I straight up killed the kernel because we did a nice little OOM there, right? So which is a common thing, right? So this is a great example. My whole point here is that like why like this is a bad practice that I've seen many times in many Spark jobs is if you call .collect like this. Make sure that it's filtered down. You don't ever want to pull in the entire data set into the driver, ever. It's just not something, that's not something that we do. So I'm pretty sure though, if we do .take5, this should still run. See how it's actually like thinking about it this time, and it's not just like barfing, because I'm not trying to bring back like, because that's a 400K times 400K. I think that's like 1.6 bill. So this is still gonna take a little bit because we're doing this like crazy cross join. Right? But the thing is this is now like whenever you're bringing data back to the driver, it should always be limited, or another way to think about it is like this should be aggregated or limited or anything like that. There should be something that happens that is the kernel like even running? It says the kernel is idle. Did I like straight up kill the kernel right now? Okay, let me try and run this again because this should be okay. There we go. Now it's alive now. I just had to refresh. So this is going to be running now, and this will actually. I'm pretty sure this is not going to OOM because see, boom, didn't OOM. Even though we did a crazy cross join here, right? So be aware of that bad practice because I've seen that bad practice many times in my career, right? And so you want to like filter this down, like either like so generally speaking, the way I think about it is like you want to be using take and show and not really using collect. Collect is the only time you want to use collect is if you know for sure that the data set that you have here is like aggregated down and you can use that as your data set. So that's something that I just am cautioning you. About because I think it's very important and just kind of showing you how like, hey, you can kill Spark. You see how I killed Spark there? Like it's great. I love killing Spark because it's like it's a fun thing to troubleshoot. So anyways, I'm gonna get rid of this cross join line because it's gonna make everything really slow later down. But let's talk about some more lines of code here that are gonna be different and kind of things here that like I want to show you about how these lines work and how we're going to split things up and we're going to figure things out. But here's the idea behind what this is going to do and like how this works, right? So you'll see df.repartition. So what this is going to do is however many partitions we had before, we're now going to have 10 partitions and we're going to split it up based on event date. That's going to be the column that we're looking at, and that's how we're going to split data up. And then we have sort within partitions. So I want to show you the difference between a couple different things here. So we have, so you see how we have this one? I want to copy this line here, and I want to, we're going to create another line here. But you'll see you can also just do dot sort, and this is going to be, we're going to call this sorted to, and then we're going to say sorted to dot show. So, because these two are actually the same in some regard, but they're also very different. So let's see if this actually works. Okay, so you'll see that one of the things you'll notice between these two is they actually pull different data. Like you'll see that in this case, we have data all the way back to 2019, the 12th, and then here we have data back to the 14th, right? So it's like, why is that the case? Like, what is the difference between these? these two, right? So that's one of the things that I think is important to talk about, because these both both are different, and they actually are very different at scale. So I want to just really emphasize this with y'all, because what I'm about to show you is another very powerful thing, but you want to make sure that you understand these APIs clearly to understand why these are different at scale. So let's talk about what it is. So it says sort within partitions, and this is sort. So if you do sort within partitions, it will just it will take every, like the 10 partitions that you have, it will look at all the data in those partitions and sort all of them kind of locally within that partition. And in this case, we're going to sort on event date, host, and browser family. And the difference between that and .sort is you'll see here with .sort, we actually get data all the way back to, like, this literally does what's called a global sort. So this is sorting data as far back as you can go. And like it doesn't just sort the data within the partitions. It does a global sort of all the data. And so that global sort like that is actually very slow. So these two, because the data isn't very big, these two, like in this data set, are going to be about the same. I think we can we do, I think we can do this. I think we can put a .explain in here. And I think this will give us what we're looking for, because we want to check out .explain. Okay, so, oh, it's because .show doesn't exist. So we'll just get rid of .show. You just got to do just .explain. Okay, so what we want to do here is let's look at the difference between these two plans, just so we can kind of understand how they are different, because they are significantly different here. And I hope that y'all can understand what's going on here. And because this is where using .explain can make a very big difference in understanding what is happening with like the difference between this sort and this sort. So in this case, okay, like we see, so the way these explain plans work is you go to the most indented thing first, and this is going to be the first step, which is we read a CSV file. Makes sense, right? And then we select our columns, right? Which is going to be, that's what project means. Project and select are the same thing, right? And then we do an exchange. So this exchange in this case is going to be, that's this repartition line, right? That's what that's going to do, exchange. And then we have our sort here, and that's going to be the next line. And there's this, you'll see there's a difference here, this false and this true. And that's going to be based on whether or not they are doing a global sort or not. And so that's going to be the next kind of line. And then you have, after that, you have the project, right? And then this is the final select, where you're selecting out the columns again. So you see that like we ended up selecting these same columns from here and here. Those are the same like list of columns. So how is that different from this one? And you'll see that this one has one more line in it though, because you see here's the hash partitioning where we repartition into 10. But then you'll see this you see this exchange here, this exchange range partitioning. You see this guy. You see how this line is not in this one? See this range partitioning here? This is the line that is going to be painful at scale. This line is going to be very, very painful at scale. So that's how you can tell when you look at these partitioning plans. Like, so what this is saying is, okay, we're going to shuffle once here, and then we're going to shuffle again. That's what this, every time you see the word exchange in a query plan, think exchange means shuffle. Shuffle and exchange. Those are like the same sort of words. That's exactly like, they're synonyms when you're looking at the plan and when you are running the job. So you'll see when you use the .sort here, you get freaking, it's nasty. It's real nasty because you get this double shuffle, right? But if you use sort within partitions, you only get one. Like you just have one. But this, like, honestly, if you remove that repartition, all right, let's run this again, and you'll see now in this case, right, there's just we have the file scan, we have the project, and we have the sort. No shuffle, right? Because I just deleted the repartition. But like in this case, even without this repartition, so if we just have .sort here, and we run, so we get rid of both repartitions, you'll see we still are going to have this range, exchange range here. And this is like,
especially if you have more than like, I don't know, like 20 gigs of data, this line is going to be very slow. Because the thing is like when you do a global sort, you have to pass all the data through one executor because that's the only way you can guarantee that the data is globally sorted. It's the only way. So my main point with this is at scale, you want to use sort within partitions and not sort. You should almost never use dot sort. Sort is like, I don't like dot sort. I think it's whack. Like I don't like, you should not think about using dot sort. So this concept right here can make your pipeline way more efficient as well, because knowing how to sort stuff when you write it out makes a big difference. And we're going to talk about that in here in just a second. Okay, great. Now, what I want to talk about now to shift gears here a little bit is around, we're going to talk a little bit about Parquet, talk a little bit about Iceberg. Might go a little bit over today, but so we talked about sorting, super important. I want to run this sorted line again, because we're going to be using this sorted line. So what I want y'all to do is also try to run these other kind of bootcamp SQL lines. Because they're going to be important here. So okay, so let's go to this line where we're creating this iceberg table. So you'll see in here we can you can partition your data however you want in Iceberg. And it's cool because like you can actually like in this case you can say years, like, or you can say days. You can even say hours here, or years or days, right? And then that will actually look at that timestamp or date field and it will just split it there. But you can also just do event date. I'm actually gonna do event date. It doesn't matter, you can keep it as years. It doesn't matter that much because we're gonna be running all the data together. So then we have that, and then I'm also gonna put the partitioned here, partitioned by event date. In this one, I'm gonna run this. Oh, there's a semicolon. So hopefully y'all were able to create your tables here, and that is working, and you have all of that working. You can have the partitioning there or not. It doesn't matter. It doesn't matter that much because like we will be able to still illustrate the point of this. So you saw how like we had our we talked about this like sorted DF, but we're gonna go back to just DF here, and we're gonna essentially do a couple things here. One is like we're gonna repartition. We're gonna have 4 partitions here because we want to talk more about like when we write our data out. So with this first one here, we're gonna do a sort, and we're gonna do sort within partitions, and we're just gonna sort on like we're gonna sort on event date, browser family, and host. We're gonna do all 3, and then the second one here, we're just gonna sort on event date. Those are the only 2 things that we're gonna do differently here. And I don't think we need this line. I don't think this is needed. Because we have start DF. Okay, so actually no, this one is not even needed at all because we're not writing here. So we're comparing these 2, right? So one of these has this like event time, right? And then it's not sorted. And then the second one is sorted. One second, I want to drop these real quick. So we say drop table. Can we drop? I want to drop these because I want the number of partitions here to be like based on the date. So can we like run this? No, you can only run one command at a time. It's so annoying. Okay, because you guys don't need to do this because like you already like have it working. So let me cut this guy. Run this, and then run this, run this. Okay, so now we have it all partitioned up, and we're going to run this repartition line again, write everything out. Great. Now in this line, line 21, we can look at the file sizes again. Well, this didn't actually finish, I guess. Like, that doesn't make sense that it's still only 4 files. Because now they should be partitioned on more. Because this is bootcamp.events sorted. How does that work? Why is there only 4 files? Interesting. Because there should be, I guess, dates here. And because that's interesting. But okay, anyways, like I want to talk more about how this works, because I think this query is probably really crazy to y'all, because this is one of the ways that you can actually look at the sizes of your data sets, right? So in Iceberg, after you write your tables out, you can then query them. Like you can query like, so you see this is like demo, this is like and then you have your, this is the highest level, then you have bootcamp.events sorted, this is the table, and then .files, this is the metadata of that table. And like, for example, let's just like run something here that is a little bit simpler, like kind of like a select star here, and you'll see, okay, so this is going to be the files that we have written out, and this is going to be all of the kind of data sets. Oh, interesting. It's because it's saying event date is like null. Is it because I don't even have event date up here? Oh yeah, okay, event date's right there. It should be there. Okay. Well, apparently it's saying out there it's always none. What, is that the case then? Hold up, because if we do a select star, is there like a bug in this? It's like, because it's like, no, okay, event date is definitely there. It's right there. It's totally there. Okay, it's fine. It's just like weird that it's not writing it out the way that you would expect. Because like there should be a lot more files. There should be 1 file like per partition. Because see, the partition here is saying that like they're all like none. And oh, because did the table not actually get dropped? I think the table must have like not gotten dropped or something like that. So what I want to try here, I'm just gonna try something real quick. I'm gonna put V2s on all of these and just make brand new tables, because Iceberg can be weird sometimes. Okay, so we made brand new tables, and then we're gonna put V2 on all of these, and then we will see if that does the thing I'm looking for. So now if we run this line of code, we should get way more files. What? That doesn't even make sense. Like there should be way more files here than just like the, okay, but see, this actually gives a lot of like metrics about the sorting and stuff like that. But one of the things I wanted to go over with this is you'll see there's like a couple things in here. You see file size in bytes. So you say sum file size in bytes. And then, oh, it's because I was not querying V2. That's why. Wow, wow. Rookie move. These are V2. Okay, apparently that it's not actually like there should be more partitioning here than just like none. There should be like it should be based on like the actual like unique values of the date. Because if this is days, right? Okay. Anyways, I don't want to like get caught up in that. Like what I want to show is, because even with this example, like it still has what I'm looking for, and we can still look at it. File size in bytes, and we want to say count 1, and then I want to say, and this is as num files, this is as size. Then let's go with this, and we want to say I want to say union all, and then we have events unsorted. Okay, so you'll see here one of the things that you get here is you see how the file size is significantly different. Like you get like 10 or 15% just by sorting. And the main reason for that is this comes from run length encoding, where if you have all of the low cardinality things together, then you're going to get better better partitioning that way. So for example, like let me show you like if we instead we're only going to sort on date and we're not going to also sort on browser, family, and host, because I think this is going to give you a kind of an example of how this works. So okay, that ran. Okay, so now you see how sorting on date was like, it helped like just a little bit, just a tiny bit, right? It's like the difference between the sizes here is like the same for the most part. So one of the things that you can do here is you really want like when you're writing your data out, you want your data to be written out from your lowest cardinality first, all the way down to your highest cardinality, like when you're sorting data. So in this case, event date is going to be the lowest cardinality because there's only going to be like a couple hundred records there. And then you have browser after that, and then probably host. There's other ones in here that you could probably put as well. There's like OS family, other things that could possibly you can kind of play around with this stuff. And this is something that you should definitely do when you are kind of like working with writing your data out. And you'll see, okay, so you see, but in that case, OS family was not nearly as good as host when you're writing out, right? Because it was like, what, it's 2 million, 2.9 million. And then what is it here? See how this is like 2.8 million? You get like a significantly bigger size reduction when you're sorting and writing data out with start df, and like you get a better compression from the run length encoding, and you can kind of shrink your data down this way. And like if you care about stuff like this as a data engineer, like you're going to make way more efficient pipelines. Awesome. Well, everyone, thanks for coming to today's lab.
Congrats on making it to the end of Spark Basics. Make sure to like, comment, and subscribe, and keep crushing it. I know you're going to get through the rest of this boot camp. you.